Okay, this is the P3 paper from October 2023. It's a differentiation question. As we can see here, we're going to be differentiating using the quotient rule. We'll do some work on logs as well when we're going through and doing it. Let's have a look at the question then. So part A says, show that dy by dx is equal to, and then we've got to get it in that format at the very, very end. I won't worry too much about that to start off with. Let's just see how far you can get with it, and then we'll look at the final answer towards the end of it. Excuse me. We're starting off with y is equal to, and we've got this quotient, as I said, log x squared plus k all over x squared plus k. And if you've seen my videos before, you'll see exactly the way that I'm going to set this out. I'm going to say that the denominator, we're going to say it's u over v. So the denominator I'm going to call log of x squared plus k. And so du by dx then is the differential of that. Differential of a log function is 1 over this part, 1 over that, multiplied by the differential of what's up there. Multiplied by the differential of x squared plus k is 2x. V is equal to x squared plus k, so dv by dx is going to be 2x. So when I'm doing my differential, then dy by dx, I always write the formula out. v du minus u dv all over v squared. I write it out every single time because it means that that formula gets in my head, and it also means hopefully I'm less likely to make mistakes when I'm subbing everything in. So dy by dx is going to be v du, that's those two. Okay, so v du is going to give me x squared plus k multiplied by 2x all over x squared plus k minus u dv, which is these two. I'm just going to write that as the 2x first, so 2x log x squared plus k all over v squared, which is going to be x squared plus k all squared. And right, before we start looking at the answer, let's at least sort that bit out there. They cancel out. So I've got 2x minus 2x log x squared plus k all over x squared plus k squared. And again, even before I look at the answer, I would take, sorry, handwriting, I would take 2x out as a factor, I think, there. Excuse me, which gives me that. And now if we compare that to what we were trying to get it to be, yeah, we've got it in the right format already there, in terms of working out what A and B are. So part B says, given that C has exactly 3 turning points, can we find the x coordinate of those turning points? So can we find the turning, just the x coordinate for the turning points? And dy by dx equals 0 is going to be the way to find a turning point. So part B, tell the examiner that for turning points, dy by dx equals 0, which means our function's 0, 2x 1 minus log x squared plus k all over x squared plus k squared is equal to 0. And quite often they ask you for a turning point or a maximum and minimum when we're doing the quotient rule, because I don't need to worry about the denominator there. If I'm solving this, it's just going to be the numerator equals 0. So that really simplifies anything that we might have had from part A in terms of our differentiating. I've got that. Remember, they asked for 3 answers, so I'm going to get 2x equals 0, x equals 0. That's one of my answers, and the other 2 are going to come from 1 minus log x squared plus k equals 0. So just rearranging this, log x squared plus k is going to equal 1, e both sides, so x squared plus k is going to equal to e. So x squared is going to be e minus k, so x is equal to plus or minus e minus k. So there's 3, they said there's 3 solutions, and there's my 3 solutions For that part C, what did part C said? So part C says find the upper limit to the value for k. So find a range of values that k can be, in effect. Now remember, k is going to be a positive constant, okay? And then let's have a look at these. So if x is equal to the square root of e minus k, then yeah, our limit on k is going to be that e minus k then will have to be greater than or equal to 0, won't it? If we're doing the square root, we've got to have this thing being positive or 0, I guess, positive or 0 there. So we're going to get that k would have to be less than or equal to, in fact, let's not underline that yet because I know there's one last clever little bit. So that would be my thought process, but it says 3 different roots. And if you get, if k equals e, what we'd actually get then is that there'd be a repeated root, wouldn't there? If we got k equals e, we'd just get 0 there, which would mean that you'd only get one repeated root for that thing, and it said there's 3 different roots. So actually that's a very clever, you might need to just read through that again. That very last bit, k can't be equal to e, k's got to be less than e, so then that absolutely defines that last part there, okay? Because it says here, there are 3 turning points, so if there are 3 turning points, then I need to get 2 different results in this bit here. Don't worry about it too much if that bit doesn't quite make sense, but hopefully the rest of it does make sense to you.